And good evening, good afternoon, good morning, everybody. Welcome on into the Dragon's Den. Digital Dragon, Luke, thank you all for joining me. Hello, Mr. Wizix and Shaudell, Stephen Poole. Hello, everybody. Come on in. So today we're going to be back to working on our Enraged Rabbit Carrot Feeder and the Enraged Rabbit Cottontail. So I have a decent amount of work to do on the Cottontail to actually get it mounted. Is the goal today is to get the two sets of parts that you guys see down here on the table, the cottontail and the Enraged Rabbit Carrot Feeder joined together. Oh, thanks, Mr. Wizix. Yeah, embrace the suck. That's pretty much the goal of these days. Uh, you know, Mrs. Dragon is out of town. Her mom just got out of surgery, having her left shoulder replaced, so that's good. But she was embracing the suck by having to sit at the hospital all day, and I was embracing the suck as dealing with the pending reorganization that's fallout after we had 5% reduction in force works. Lots of stuff going on, and that's about the best thing we can do is just embrace the suck. So, oh, thanks, Mr. Wizard. He came out of surgery fine. It's just, now he's already had the right shoulder done. So it's just a matter of, getting out of the hospital, getting home, starting the rehab. No big deal there. Um, I'll say we've kind of been around that block once. So I was looking at a couple of things, and before we start to mount the arm, we need to actually kind of finish putting our last couple of coupler blocks together. So we've got, I think, 6 of the 8 already done. We just need to do the last 2 that I needed to reprint. These prints came out really good. I think I am going to put the LEDs on the back, but I may not do that on stream. We'll see. It's not going to be critical to getting it together and software installed and working. So I think I'll just work on that a little bit here and there on the side. All of that broke. But I'll go ahead and take these little pieces out. They're just print in place supports and where the LEDs will go into the back here. We'll get them printed if the lights don't really provide much information because these are very much opaque and not clear or translucent, then I'll consider possibly reprinting these blocks somewhere down the road or redo it on the second one that I'm going to build. But for now, I just want to get this whole system done and built. And as we learned from the last time around, it is so much easier to take the rubber piece off the bottom here, and we'll set the blue piece in first using our Nipix pliers. No pressure. That's set. Make it sound like, yep, gentle pressure, and it'll get set just like that. Okay, coupler works. Then we'll go ahead and put the rubber part in. We'll do that to all 4 of these, and then we can actually set the couplers. So how's everybody doing today? Hopefully good. Like I said, just org stuff notwithstanding, things are going good in our life here. We're just dealing with a lot of change at work. So kind of how things go sometimes. Anybody know if Facebook came back up today or is it still down? Curious to hear all about that and all the security chat. More info comes out about why it was. Okay, now that we've got our ECAP settings together, we're just going to take these and push them in. We'll be able to get them in nice and easy. If we need to, we can use the table, but the greater you get these going in, easier it will be. Yeah, table and give it a press. Hey Timor, how's it going? Welcome in, welcome in. Second, folks. There and put it on stun. And colors anyhow. Looks like most are back to normal. That's good. Yeah, I very rarely get on Facebook anymore, and when I do, it's just to look for family, updates from family. Friends probably think I fell off the planet. Okay, so now that we got those in there, the next thing we're going to need to do is pop in our bearings. What bearing? 5.5 ball bearing. And I know I have the bearings, it's just which file here. You guys remember which one I put it in a while back? Was All right, am I going to make a liar out of myself? There they are. One place I didn't look. Hey, Rodney Mac, how's it going? Doing good. Like I said, we are just embracing the suck. So just going through a lot more change. They just had some more high level reorg stuff announced at work. So, and that just came out right at the end of the day. So, yay, fun times. A little more churn to go with our lives these days. But oh well, keeps it fresh and keeps it exciting. Right? We're going to need some of our M2 by 10 or M2 by 12 self-tapping screws, which is what I grabbed there. And we're going to take our blocks, and we just need to do the next two in the series. We're going to take our block, we're going to hold it so that the hole, whoops, there we go. We're going to hold it so that our hole is right there at the bottom. That's what we're going to put our ball bearing in. So we'll pop a ball bearing out. Drop it right in that hole there. And then we're going to take the next end stop in the series, line it up so that the plunger lines up with the ball bearing, and we will secure it with a couple of M2 by 10 self-tapping screws. Once again, this becomes basically we'll have a filament runout sensor, and then we'll have two sensors in the tool head. They'll primarily be used for awareness of where the filament is in the filament path. That will also help us troubleshoot our with the Happy Hare software. Once again, we'll flip this around so that the end stop is oriented right. And the last end stop has two wires on it, and that would be, we'll call it the signal or the trigger wire, and the common ground wire that's linked between all of these. So when we go to install this on the Enraged Rabbit Carrot Feeder, we need to make sure and start from lane 0, which would be the end with the longest signal wire, because that signal wire is going to travel all the way down and in. So let's have to be aware of that. We've got all of our coupler blocks finished. We still need to throw our PTFE tube in these. Got all of our end stops in, and now we're going to start building the actual, we'll join these two parts together. So we're going to start, and I've gone ahead and put the lane numbers in here. So we're going to start with lane 0 and work our way all the way over. So I'm going to basically stick this stack this way and just take off the end nut so that I can pick things off this stack one at a time. And our Enraged Rabbit Carrot Feeder, we still are going to have to do some wiring, and we'll get to work on that. But I'm going to lay it kind of on the selector switch here, because as I join the Enraged Rabbit Carrot, not the Carrot Feeder, the Enraged Rabbit Cottontail, it's going to start right here with this first lane, which is the 0 lane. That's where we're going to start. Each one of these lanes is going to get put in with a M3 roll-in T-nut and an M3 by 8 socket head cap screw. So we will grab those. Oh yeah, Timor. It's one of those things that I've already been talking with Mrs. Dragon, and once my time here at Cisco's done, I don't think I'm going to be doing like big tech anymore. I may take something here local and smaller, but it's not going to be big tech anymore. And I had tossed all of the M3 T-nuts just in here after the last stream. So that's why I'm going into my stash instead of in their box. This is still theirs. I'm just grabbing it because I threw them in here. I don't know how many I'm grabbing. I'm just grabbing. Orientation looks like the actual screw hole is going to be facing the left. So that's where we're going to get started here. And I'm going to move it this way some. I'll probably just go in and preload these. All right. And seeing what we're seeing, we're going to take our first lane bracket here, right? Our in lane bracket with the 0. And we're going to line it up and we're going to use an M3 by 8. Go through this hole here at the bottom. Started in our through here. Be able to scoot that over some. Because the next part's going to be the fun part. This is where we start this gaggle. So we've got the furthest end stop and trying to work around the wires here. So this end is going to go into this ECAS fitting, and then it's going to plug into the side here. So and it's going to face downward, so it's going to be a downward legged L. So the filament comes in from the bottom up through this area here. We'll go around the buffer, then come in through this side through the short PTF link into our gate. That way, these depressions here will line up with the little pegs on the arm, and that's what's going to help link everything together. We're just going to push this down into the ECAS fitting and make sure to get these bloody wires out of the way and get this lined up and linked on there. Then what we'll do is I'm just going to grab the second one. And I want the one wire going up. So the wire that joins all of the linked ends, I want to stay kind of above. You'll see what I mean here in a second. We're going to have to, dang, this is going to be, I have to take this back apart. Take all the lanes out. Because I just realized what I'm going to need to do here. There we go. This is going to have to go all the way through because we're going to have to put the pulley on for the buffer before we put the next leg on. We need the pulley on, and then we'll need a spacer. blue spacers. That's going to go. Then we'll take our next leg, which has a built-in spacer on it. That will go on here. And then we'll be able to rotate this down. This is where I said it starts to get fiddly, especially with wires. So this leg comes down, line it up, and link it onto the previous coupler block. Push everything together. Next coupler block will go on. And then we need to slide over and line up our T-nut so that we can screw this down and it starts to get a little more rigid. And you'll notice that like I said, the one wires I'm keeping above, so the jumper wires between the lanes on the end stops, I am keeping above these brackets, and then the other wires I'm going to bring down because there are zip tie slots here, so we should be able to bring them down through all of these zip tie slots right down through the end. That's hopefully the option there. This here, that. We're going to need the next buffer wheel, preferably with pushing that out. Another one of our spacers. Then we'll need the next lane leg. Figure out what our next coupler is going to be. Ooh, oh, that one. Oh. Almost kind of like I feel like I need a lamp. Trying to keep some of these things stuck together while I'm working, so I don't keep pulling things off. Problem is I don't have a, like a spring ratchet clamp. That one's there. We need to bring this one back. Line up this bottom M3 T-nut. Hey Zombie, how's it going? The ERCFA is going good. We're in a fiddly stage. And that fiddly stage is playing with the wiring and getting the lanes and the coupler blocks lined up and in place. Because each coupler block, has a wire that joins to the previous coupler blocks end stop. So that one needs to go above and stay above the lanes here, while the other one needs to come down out the back. But I put a lane in. Now I need to grab the bearing wheel, or we'll call it the buffer wheel. Put that on. A spacer. Put that on. Grab the next lane. Slide that on. Making sure that we're keeping the wires where we need them. And the lanes locking into the previous coupler. So we got to get this so that that lane can come down, lock into the previous coupler. Okay. Then we can push our T-nut over, line it up, add our screw. So yeah, it's just a little fiddly. Okay, now our coupler block, we need to get that properly aligned with the making sure that our long wire is going to be coming out down underneath the lane and the other part staying above the lane. Recast fittings, and up the pegs and slots. There we go. And rinse and repeat. So another bearing wheel, spacer, next lane leg. Figure out where this has got to go. Rotate it down. And at some point, once I get these put together, there's going to be screws that go. So you got all the I'll say the lane mounting legs down here that are locking things together, but we'll also have screws that will go right in here and will link each one of these. So I believe it's going to be the M3x8s as well that we're going to take, put in here and screw each one of these together as well. Just like so. And that's going to be all three of these pedals as we go around. So I'm probably going to do at least a couple of these now because that will help strengthen this as I keep going forward. Okay, we'll keep going. So arm, uh, buffer wheel, spacer, next arm, right location, And up with the previous coupler block. Go. Hey, Pezliz, how's it going? He exists. Ouch. Man, Pezliz, you're in a good mood today. Okay, so we're going to take that next block, and once again, we're going to twist and turn it however we need to so that the jumper between the previous block and this block stays above the line, and the other one falls down in the gap here in the lane. Stick that together. Make the block match. And then we'll grab some more screws. Hey, Pete, how's it going? Welcome in. Let's see. Timor, Rodney Mac, Nick, Zombie, Pez, Pete, Shaudel. Welcome in, everybody. Welcome in. So we're going to take this one and pull the lanes together here in the back. And then buffer wheel, spacer, next lane, right up here out of the way. Sure that it connects in with the previous block. Seriously, a line, darn you. There we go. That's aligned. Now we just need to push our peanut over. Yes, you can. So Stephen, this is a ERCFA 1.1 kit that came with the Trident 350, and I purchased the V2 upgrade that takes a 6-lane V1 to an 8-lane V2. I purchased it off of AliExpress. So, you know, the standard rules apply when you're buying things from AliExpress, but this was a Triangle Labs upgrade kit off of AliExpress. And so far, it's had everything I've needed. I think there was one screw that was missing, a specific screw size that was missing. And I'm not sure, you know, what the dealio was there as to why just one was missing, but one was missing. This is going to be for our last lane here. So we make sure that this is pushed out here. This is coming through there. You get back on there like you're supposed to be. Thank you. You get on there and line up too. That. This comes down and lines up just like that. Start being all persnickety already. Gonna have to use some tweezers to get that one lined up. And 3x8 loaded up and lock that in. Really? Don't talk back to me. Here's the last one wants to be pain in the tuchus. Okay. Pretty good. We have our last segment here, and this one's going to have 2 wires coming off of it. Go ahead and link these buffer pedals. Oh, like I said, this is a Triangle Labs kit. We'll take a look on AliExpress here in just a second. I'm trying to remember off the top of my head what it cost. Let's see. AliExpress. Yeah, so full display. So it depends on what you're wanting and what you get. So the 8-color Enraged Rabbit Carrot tail inline buffer. What is this? This is a ERCT V1 6-channel upgrade to V2 8-channel. You'll have this is for the upgrade with the board. Yeah, so it just depends on what you need and how much you get and what all you're getting with it. I want to say this is the one that I got, and this is the 8-channel with the Enraged Rabbit Cottontail buffer system. The ERF, the Enraged Rabbit Filametrics, which is the filament cutter in the tool head, so the parts to do that. And then THS, I don't know what the THS, without the control board because they didn't have the version with the control board, which is more expensive, but they didn't have that version available. And I just bought the control boards together through Amazon, I think. I got the control board and the TMC 2209s to use with it. So it's not bad, especially if you've got an ERCFA with a control board already. You use the same control board. You're just changing some of the physical build and mechanics. Give me 1 second. I just dropped a part. This is new. Dropped my last spacer. Not good. Not good. Where did you go? There we are. Yeah, so um I grabbed one from the Triangle Lab, and I also grabbed one from um the Lead Labs, SELEAD Labs. So I got two different kits. The one that we're putting together here that you're seeing is the Triangle Lab kit. And once again, it's the hardware, not the printed parts, just the hardware. So we've got the last buffer wheel, the last spacer, and now we're going to have the end piece that pops on. I know which way this goes on. And this end piece goes on, and there's a screw at the end that goes into this last lane here. Oh, whoops. Now we come back here. Repeat these steps with each arm. We put the insert 4 M3 heat set inserts into the holes on the flat side of the support arm end cap. Yep, hadn't done that yet, so we'll take this back off and we'll put our heat set insert machine up here, and we will put those heat sets on here before we do anything else. And we just need to put them in the 4 holes back here, because that's what's the controller board's going to connect to. And we've got our M4 hip-ons from doing black box. We need to take that off and swap that out for the M3 tip. Yeah. Yeah, and like I said, if you have an ERCT Easy board, there's no need to upgrade to the MMB. There's a side plate just like this for the ERCFA board. So there's no need to just go in and pay for that upgrade unless you really want to. And I have both a standard ERCFA board and a Mellow Fly CAN bus version. Hey, Mac Mice, welcome in. Thank you for the first time chat. And we're working on the Enraged Rabbit Carrot Feeder, and we just added in the cottontail buffer system. So this is the Enraged Rabbit Carrot Feeder version 2. Bear with me here, and I need to put in some heat set inserts on this piece. Just swap that tip over. And once we get those heat press inserts in, we can get that mounted. So the Enraged Rabbit Carrot Feeder is a multi-material unit for for anything that's Klipper related. It's primarily it was designed with the Voron community in mind, but it works with anything Klipper related. Just like the trad rack is designed by the Annex Engineering folks, but once again, it will work with anything that's Klipper related. And I will say now, mind you, that the base firmware may be more tailored to, in this case, a Voron versus something else. So if you put it on something else, you might have to tweak it a little bit, but your mileage will vary. Um, did notice that this part does have a little bit of a warp to it, but it's an end cap. I can live with it. It's an end cap, and it's the rear side of the end cap, so I'll live with it. You know, Steve Bills isn't here. Would probably cringe if he hears me say that, but so the multi-material units, whether it's a Prusa MMU, a Enraged Rabbit Carrot Feeder or ERCFA, or a trad rack, or a SMUF, which is another open source MMU variant, the Chameleon, they're all kind of the same. It's enabling you to run more than one color, and I'll say filament class or type through a single nozzle. And the reason I say that is you don't want to do, say, TPU and ABS through the same nozzle. They're going to be massively different temperature ranges. And I guarantee you may go from TPU into ABS and the ABS prints, but when you go back to TPU, you're going to have a clog because the ABS won't be fully cleaned out and the TPU is not going to be at the same temperature, and it's a softer material and it's not going to be able to push its way through. So I'm going to put this plate back in position and put the screw back in to hold it at the side here. Okay, we're also going to have another knob at this side. That's going to hold our buffer wheels kind of together. Don't get it too tight. They all need to still spin freely on their spacers. And we're just going to go through and continue to add our screws to lock everything into each other. And once again, all of these wires are going to come down and go into the box. Now it looks like bringing them down will not get them to the board because I do know that the case and the way our case mounts, our case is going to mount like this. So all of our wires come up through this front center point. which means all of these wires are going to have to run kind of down through this trough to come into the board and have enough room to extend up there. If not, they're going to be short and we're going to have to extend every single one of these wires. Hopefully we don't have to do that anyhow. Our other wires here, we're going to have to see about the same thing. Like I said, there are zip tie points all the way along here. So common sense would say we should be able to take all of our motor wires and the selector wires and stuff and run them straight down here via this zip tied channel, but they're not going to be long enough. So we're going to have to extend these wires to get them there. These wires still may be long enough if we run them through this top trough. If it looks like they're not going to be, then quite honestly, I may make a custom harness plug versus, no, that should get it there, but I'm going to have to do it coming up and over. And honestly, I'm going to bring them up and over one at a time as I'm crimping them and installing them, because if I don't, I may lose sight of which one of these is which lane wire and have them connected to the wrong places. I'm just going to hold these down. Also note, we can have LEDs here, and I will put the LEDs here and see if it helps with lane indication. But those are going to be joined in series. And then this last one is just going to kind of go up through that channel around and into the board here. Our servo wire needs to be extended out. I'm going to extend it out most likely to match the length of this one. And I don't want that clip there, so I'm going to have to cut this off and solder the wires in, because this is going to go in our cable chain and kind of do the loop around and come back. And this would wind up with a connector in that cable chain. And connectors and cable chains are no bueno. So we'll want to extend this wire directly. So yeah, we're gonna have some wiring to do. And we'll get there. For now, I'm just going to continue to put all of my screws in to lock all these together. Yeah, it does look like a like some type of scoop system, like a mining rig scoop system. Oh yeah, I agree with that one. The fact that there was an issue with the printer, okay, that's one thing. But when you say, "Oh, well, you're past your whatever return date is, so you have to pay for shipping yourself," it's like, wait a minute, you and your staff took 2 weeks to respond, and it's a 2-week window before returns are costing. So no, that to me borders on scammy behavior. Um, so yeah. Now, one thing to note on here is you do have to get your lane indicator numbers, if you're going to use them, put in before you assemble all these. Otherwise, you're not going to be able to get them in there. And there's a part of me that wonders, like it talks about assembling it one lane at a time. I kind of wonder if you can't put this whole contraption together and then mount it, The only hard part would be lining up all of the PTFE tubes. I think that would be the biggest problem, is just getting the PTFE tubes lined up. So this one's done. This one's done. We need to run the screws in to join the front end. And these are just threading into plastic. And it is at an angle. It's not a straight shot. It is at an angle. So be aware of that and make sure you get your angle. Keep that angle and it'll screw in very easily. Yeah. You did them separately and put them together. Okay. Now I did just see that the trad rack over the weekend, I was getting ready to start setting up to print out all the trad rack parts, because when I built my trad rack, it was during the closed beta, and they've been in open beta for a while. And I'm glad I didn't, because they just came out with release candidate 1, which is the the actual release, the first release candidate out of beta. So that's pretty good. I will be printing the parts for that and tearing mine apart and rebuilding it and mounting it on the Annex Engineering K3. Um, so this is going to be our Enraged Rabbit Carrot Feeder. Like I said, I need to extend these wires, which we can work on tonight. I'll need to extend these motor wires. The in-stop wires are going to be plenty long enough to lock in underneath, come up, and go in. We need to mount our board with 4 more of the M3x8, so that's good. And so, as I mentioned, I bought a board with 4 drivers, because that was the set, and somehow I got 2 boards with the 4 drivers. So okay, CAN bus cable. That's going to be our board, jumpers, the USB A to C rubber ducky. Uh-oh. There we go. We got a squeaky rubber ducky. And for those of you that are new or see, but that's my rubber ducky. And I'm sure I've got a few hanging out at other places that I have not thrown in the bucket yet. So we support Big Tree Tech here on this channel. Well, I can probably take big tree tech stickers to Rocky Mountain Rep Rap Fest and uh, stock them, keep them restocked. Yep, a lot of ducks. A lot of ducks. Okay. Like I said, we do have a spare one. We are going to build a second one of these. I'm not sure if I'll do it on the channel or not, because we've gone through the series once already. So but we do have another one that we can use and another hardware kit as well. So we'll be good there. Yeah, that type of paperwork. And the way it looks is we use, yeah, so we've got motor 1, 2, 3, 4. We're going to use the first two here or the middle two, and the board's going to mount underneath like this. Put drivers in these two slots. And they are keyed to only go in one way. Let me see if I can force them in. Actually, before I do that, you need to put the jumpers on here for whether they're using the voltage input or if you're running a higher voltage into them. So on these, it's a 3-pin jumper. We want the first 2 pins to be the input voltage, meaning it'll take the 24 volt that's being supplied from the CAN bus. Need to jumper the diode pins. There is a 120 ohm resistor, but my understanding is you only need 2 120 ohm resistors if you're daisy chaining them. Now, I don't know if that's considered daisy chaining when you go into the 2 ports that are on um, the main controller board, or if it literally means like go from the board to this board and from this board to another board, that's the daisy chain. So we'll have to see. But once again, the board will mount in this orientation. So line that up. There are 2 little depressions for the 2 keys over here. Say 2 keys, but it's the boot and the reset pin. First one's not going to line up because of the um whatchamacallit, the warping of this part and up all the way. So I wanted to put these in before I put this on because it was sense. Push this down in there. Pushing your RAM in. There we go. One in. Two in. And I will most likely leave this sitting like this as I try and work on wiring, just because I think it'll be easier being work. And we're going to be in a position where we're going to be working on wiring now, I believe. Now that we've got the board installed. So do you guys want to do some wiring, or in this case, it'll be crimping. I think for now we've got everything screwed in that we need to screw in. We're doing some crimping. We'll have to do some cutting and soldering in a little while. But 6:30. Now the other thing I will tell you is I did look and I found mounts that will let me run two 2020 extrusions across the top of my printer and just mount it with a couple of M5 screws. Now my plan, because I believe the extrusion that I have to double check. It's because I haven't opened the box, but it's either silver or black, which of course I've got a white frame. So I'm going to have to go and order some extrusion links from DLL PDF and get those custom painted as white to go with this frame. But the thought is I'll go ahead and cut the lengths that I need for the bigger one. And once I get the right colors in, I can swap it out and just recut those down to a 300 size to mount it on one of the 300s. We're going to do crimping, so I need wire strippers, wire crimpers. Well, thanks, Sally Prince. How are you doing today? Like I said, we just mounted our board. We're going to start doing the wiring back here. These are all the end stops that are going to go on this top the top row here, and they act as filament sensors. So I'm going to feed those through and start installing those one at a time so I make sure and get them in the right order. And then so all this is stuff that they gave me in the Trident kit. I mean, insulated spade connectors, fork connectors, plenty of Molex connectors. So basically what they did was they gave me connectors to wire up the printer as if I was wiring things from scratch. And what I did was I bought a Lineo under the deck wiring kit, which wires everything up underneath the deck. And then we were using a CAN bus full head board. So we just have 4 wires coming off of that. So we didn't really have to create any wires, which was nice. Now, I've got my own sets that are already opened up, but I'm just going to grab one of these. I've got 2 different sets of JST connectors in here. These might be the smaller size, or these look to be the normal size. So we'll use this set. Basically, because I don't want to go dig mine out. So they might be behind me. I've got so many of these sets, I could probably wire like 5 printers without needing any connector bits whatsoever. What I want to see is these are 3-pin connectors. So how many 3-pin connectors? And I think that's going to actually come pretty darn close to all. So looking at the diagram, it looks like the common ground. So we're looking at this gate 7 here. The common ground is the middle pin, and then the top pin of every single one will be the one wire that goes into all the rest of them. So gate 7 starts at the very first one here, which is stop 10. So again, let me figure out my 2 wires. Easier to go on this side. Oh God, yeah, don't even get me started. I want to say these are XH connectors that I'm getting ready to use. And then PH would be the next size smaller, if I remember correct. All I know is that they get tiny. The ones that they use on the um, Big Tree Touch, Big Tree Tech EBB SB 2209, not the uh, not the Raspberry Pi version, but the standard version. Those just need to be outright banned. They just need to be outright. Those things are the most horrendous things made. I think I'm working on about a 10, maybe a 15% good rate on crimping those. Majority of the crimps I do on those crap, but I wind up breaking the wire or don't get it tight enough and it's off or something. Southeast. Yeah, he pretty much says he's pretty much in Detroit. Like when he flies places in the States, he goes, or even when he went to surf, I think he went down to Detroit and then flew out of Detroit because it's easier and cheaper than flying out of Canada. That one's done. Feed that up and around and plug that one straight in. Okay, so there's our first end stop. We're going to go through in one lane at a time, do the signal pin, which will be the leftmost pin, and we'll just go right up the line here for all 8 of our gates. And that's because we've linked all of the grounds together already. So there's a common ground each one of these signal pins. Oh, they're well, it got to the point where they're actually supplying um jumper wires that are pre-crimped with those connectors on one end. So I'm just literally I just cut and solder my wires to those and I use those pre-crimped connectors because those things are so painful. The only thing I've attempted to try and do on those connectors is the actual heaters because I don't like using solders on the heaters. Don't have since the heater pins are normally long enough, I will trim those to size if I need to. Thermistors can drive you some weird readings as well, but I had pretty good luck with just soldering thermistor. Hey sis, how's it going? Hope you are doing well. We are doing just grand. We have gotten the physical build done. Now we're starting to do our in-stop pins. And we're working our way back one lane at a time. We have our wires for each lane sticking out. And we're just working our way down one lane at a time because our first lane is at the bottom here with two wires that go to it. So it has the signal wire and the common ground that all of the end stops are connected to in series. So each one of the next lanes is just coming over with a single, um, whatchamacallit, single signal pin. It comes up and into, and you'll see that we do have 3 points right here where we can run some wire or wire ties, zip ties. So as we need to, we'll be able to bring the motors and other things up and go right down here, do some wire man. Right now, it's behooving me to go one at a time and do this. Sorry, I'm trying to check messages periodically because my mother-in-law just had surgery today, had her other shoulder replaced, left shoulder. Hey, Maker Mind Nexus, how's it going? Ah, so you're kind of stuck out in the arena because of the rain? Oh yeah, I bet. I bet. Um, that's one of the few things where my bed where I sleep, I've got the downspout right outside the window, right at the corner of the house. And I love hearing the rain, as long as it's not like a torrential main thunderstorm, just gentle rain. I love hearing it just pitter patter its way down the drain pipe. Pretty peaceful. So there's a probability that I can come back in here and try and zip tie these, but right now they're all laying kind of nicely and down, so it's not that big of a deal. And Dan, you were talking, you had one of your students that you just gave one of your printers to. Have you been able to get it home and get it set up? And these wires that I'm using here are Lineo 24 gauge FEP wire, which I love the Lineo wiring, love the FEP wiring, except when you're trying to, um, one, strip the end, just because the wire is so hard to grab hold of the wire and get the wire to actually do what you need it to do. And then the other piece is what was that I was just saying? Um, The other piece, of course, is just the it's small and tight, so it gets a little fiddly as well. It's rigid, but it's not. So when you're trying to do a crimp, especially that second crimp, it's real easy to fold the pins over on it. Where silicone, you got a little more bulk for it to grab into. Hey, Tweety Verdi 777, how's it going? Welcome on in. Kit Skyfire, how's it going? Emotional tie-in size for Starbucks. Sure. Having it shipped to the school, and the student and I will be building. Oh, nice. Nice. Mess with that. The what kind of printer was what kind of printer is it? What are you going to be putting together? Oh yeah, that's normally what I do, Pez Liz, is I'll have my Yeti, which is like two Keurig pods, and then I'll make a regular cup as well for the stream. But I didn't do the regular cup today. Let's say still some changes going on at work, and I think I've been drinking too much coffee, which is getting me a sour stomach. So trying to be mindful and not just slug coffee down. Well, that and I think with everything going on, Mrs. Dragon out of town, I staying up later than I should. Coffee's not helping that. Good, good, good. Glad you're here too, Tweety. Hey, Darth Gollum, how are you doing, friendo? Good to see you. Good to see you. We are just doing some wiring and crimping. Rather than having my Crimping Ain't Easy shirt on, I got a shirt that's just as prophetic for this day, which is embrace the suck, right? So we're embracing the suck that is crimping 24 gauge FEP wiring and trying to route said wiring. Oh, you got to talk in front of bigwigs. Uh-oh. Yeah, I'm having to do some things like that too. Right now, I'm a direct report to a VP. So until we get the whole reorg stuff figured out, I'm having more conversations than I want with the VPs. Those out of the way if this keep flopping back in my way. Yeah, there's Danger Den. Welcome in. Well, need somebody that can talk about the needs and why it's important. So I think you can handle that part. Just remember, you need 3D printers and a Milo mini mill. So sitting here watching Steve builds and Nero do their Milo builds and starting to get antsy for my kit, but it's going to be a while before it's going to get in sometime after uh, Rocky Mountain. So I've got plenty of time to wait and watch videos. Once I get these last two finished, I'll show you what I'm doing here. I'll bring you in and show you a little more close up of what I'm doing. You're going for a Tormach. Well, there you go. That's even better. Well, why limit yourself? Go for the Tormach because the Tormach you'll have like the industrial grade stuff, but also go for a Milo so that you can actually do the project of building it with the kids and actually showing them the basics of what the machines are in the background because you're never gonna have them open up and service a Tormach or a Stratasys, right? Because you just void the warranties on those things. But if you do a standard printer like a Prusa or do like a Milo mini mill, one, they can see both ends of the spectrum, and two, they get to see the inner workings of the tech. Yeah, you'll still have your Prusas. Yeah, somebody was asking about 3D printers. I've got a couple of 3D printing groups in the at work, and we had somebody that was asking about a 3D printer to do like 300 cube minimum size to be able to do engineering prototypes on and stuff. And I'm like, we're a networking company, guys. What kind of engineering prototypes are you doing? And you're saying this is going into a lab. I started asking a bunch of questions, and I was like, well, I know we have a Stratasys in one of our buildings, but it's been there for a number of years, and I'm pretty sure it's out of warranty and in much need of loving care because I've never heard of it actually working in the 7 years that I've been there. Now, would I want to lay hands on it and try and make it work? Yeah. I'm pretty sure if it's out of warranty, I could talk them into letting me work on it. But then I'd have to go into the office. And why do I want to do that if I can help it? I've got printers I can play with here. Yeah, I use Tormach to machine the parts for the, or even better, Darth Gollum, because it's a fab lab, right? Ivan Miranda actually has a steel. He has the plans for a steel CNC mill that he built, and he cut the parts out on one of his smaller machines, and welded everything up. So that would be a good thing. Get the you know get the plans for that, and have them fabricate that on the plate parts on the Tormach and weld everything up and stuff. There's all kinds of cool things. See what happens? Oh, that's awesome. Let me know if you need somebody to go with you on that tour or Stratasys. Sure, I can figure out where are they based at? Yeah, teach. Come on, with me. And do it. There we go. All righty. So what we've done, um, ah, get up, get my foot out of there. Ugh. So what we've done, and I'm gonna probably in 1 second here. We're gonna use trouble is showing things, especially black wiring on a black table. It doesn't go over very well, so I need something to put underneath the bench here when I'm trying to show this. So, so what we've got going here is you see the loops in the wires, and that's the ground loop going between each of the end stops that are underneath the coupler blocks here. And then you'll see the other wire that's coming out, and those go around, and they're linking in right here. So lane 8, which is the farthest right lane here, I should say lane 7, is in the last end stop. And that's the one that has 2 wires. So it's got the common ground and the signal wire. And then each one of the rest of these just has the one wire at the top of the connector for the signal, because they'll all switch through the common ground. So we've got all of these done. Next up will be, we'll need the encoder wiring, which is this this wiring here that was pre-terminated that goes through the cable chain, the servo wire, which we'll have to extend, that'll also come through the cable chain. And then we'll have the motors and the other end stop from bottom. So we'll probably work on extending the motor wires, because this motor here is going to be a quick, easy connect. We're going to have plenty of leftover wire from that. So work on that. We'll work on the 2 motors next. Flip this back up on its front, side, top, whatever we want to call it. We'll have the motor wires. Now this is the selector motor here on the top, and the selector motor is motor 2. So second one here. And then the motor coming from this other side, which is the gear motor, it will come all the way down here, come up, join the wires coming in, go to the first motor connector. I went to Rocky Mountain, Murph, and Earth last year. I'm planning on doing them all this year as well, as long as I have the leave to do it. And we don't have any more issues in family during. But I am planning on going to the Earths. Now, Rocky Mountain, I can't bring a lot of material because I'm not driving out there. I'm going to fly out. My wife's driving, so she drives the smaller of the 2 vehicles. And so therefore, we're not going to have um, as much with us at Rocky Mountain, but we will have some stuff there. These wires, once again, are going to get zip tied here. They'll come up into the side of the box here, and these two are going to connect in the bottom connector right. And these are the motor wire that's going to be extended. This motor over here, what did I do with that one? One second. That wire's over here. So, don't know why. But they have this listed as an EN stop. This is, I don't know why. And I mean, it's a pancake motor, so you could have used it if you were doing like a CW1 versus the CW2. We did a CW2 and we had an appropriate motor to do a CW2. So what we're going to do, it's got all kinds of tangled there. That's all. Is we'll take this side, jumper connected in here. We'll bring this over, down, figure out what our length's going to be. We'll cut these here. We'll terminate this one, and then we'll use this excess, because we got plenty of excess, to extend these 4 wires out and go into the other connector. So either way, good. Yeah, because I like reusing wire when I can, especially pre-done wires, and especially when I've got, like enough length that I could have probably run this thing all the way back to the under chassis. Hey, Big Jano, how's it going, friend? How is it going? We're doing good here. We're just we're doing some wiring. Wiring is fun, right? Um, oh, nice, Darthalum. Yeah, some of it's going to depend on travel prices, and then other parts will depend on, your hotels and where you stay, how close you are to the venue. But I can get you some prices for Rocky Mountain. I think I have like my stuff from the other two from last year. You just have to, I'll say, extrapolate up or add a percentage for inflation, cost increases. That I'm just going to get these 4 pens crimped and then I'll put them together. How's things going, Jano? Doing well. Is work calmed down a bit for you? I hope so. I just saw you made the comment about decompressing. Guess it has been another long work day, huh? Yeah, my work hasn't been like the work part hasn't been crazy. It's we're going through reorgs and stuff, and they just announced some changes at the executive vice president level, which is going to have impacts all the way down the org structure. So we've got to figure out that and who the hell we're going to be reporting up through and all that funness. Oh yeah, that would be nice. I mean, there's a part of me that says if I bring my Death Racer to shows this year, once again, it depends on how much stuff I can put in my wife's car as to what I bring with me to Rocky Mountain. Um, but if I can get some of the racers and stuff, I may let somebody else run it, right? Just have like, okay, have one of the kids run this. I think that would be cool. All right. And black, grab black, green. So this is the easiest time to do this when you've got your wires unplugged like this. Take two of them, hold two apart, take the other two and hold them together by their pins, and then try and move your motor. If it moves freely, then you don't have a pair. Um, and if you're not sure, just grab a different one of them. Try that. Guess it would help if I didn't have it sitting on the selector that I'm trying to move as I'm doing this. But you should be able to feel a difference, almost like a little bit of a catching with it'll be a little more difficult when you have a pair together. So in this case, it's the black and green that are a pair, and then the red and the blue are a pair. So you can go ahead and try and get these set up and lined up, at least in pair formation. And then that way, if it's going the wrong direction, you just need to change the directionality in your Klipper software. But you're not going to have an issue where your motor's out of phase and it's just stuttering and making all kinds of grindy noises. Once again, this one is the selector motor, is going to be the closer of the two motor inputs here. And we'll do some wiring cleanup there if we need to. But now that we have that one done, what we'll be able to do is figure out about how much of this we need to extend out. drastically. And we have an option here. We can use the side that's got the crimp already on it, and then that gives me just 4 lengths of long wire or colored. Or we can use the wired end to make our extensions and then cut and recrimp to length. So we've got options. Either way, we're going to have to solder at one end. It's just whether or not we use the existing crimped terminal or not. We did that. These down, up. Need now that's going to just leave me a bunch of excess wire here, once again, in 4 different colors, standard motor wire, that I can use for various other things like droid projects and stuff like that down the road. Going to get this pulled up, bundled up. Hey, Joe Mike Makes, thanks for the follow. Thanks for coming in and hanging out with us today. I would say like I need plenty of more wiring. I don't. Now we've got a couple of different things that we can do for this wire. And I'll say, cheat and go the easy way, which is I'm going to use the soldered like butt joint connectors here, heat shrink butt joint connectors. So these have your heat shrink, and right in the middle is a band of solder. So you get your bare wires in the middle part there. You heat it up with your heat gun, and it will heat shrink on both ends and melt the solder, and you've got a good butt joint connection. All you have to do is go through and do your wire ends here. So we'll strip these some. And in the case of these, those butt joints are going to be along the bottom here where they're fully supported with zip ties and not going to be seen. So that makes it even better. Or isn't going to be readily visible. These thrown away. We need to grab the heat gun and get the heat gun out. Because with the way these wires are, they're going to be finicky, and I'm going to have to do them like one at a time rather than get like all 4 prepped and ready to go and then hit them all 4 at the same time. Hey, Hobby Main, how's it going? Welcome in, welcome in, welcome in. We're just working on some wiring. And right now we're going to extend our motor wiring. And like I said, what we're going to do is we're going to use our heat shrink solder connectors here. Make life so much easier when you're extending wires. Put the one wire in, make sure you get the appropriate color on the other side. Doing the green wire first. Make sure you cut off a decent amount of the ends so you have plenty of wire to overlap within this solder connector. Line the wires up at the middle section where the solder is going to be. Then you just take your little heat gun with your shield. And this will shrink each side onto the wire. And then you want to heat up that solder in the middle and let that solder flow. And when you first do this, it's a little malleable. So if you need it in a specific orientation, now is the time to kind of put that bend or kink in it, and it will stay that way. I just need it to go straight. And like I said, we're going to be able to bring this down. We'll have zip ties right on each side of that joint. That'll be good. Was the green, now we'll do the black. Like I said, I'm just making sure that the stripped ends of the wire are crossed like that in the area where the solder joint's at. So I can heat up both ends and then um, concentrate in the center, and that will melt the solder itself. That just slipped. All right. Don't pick up the hot thing, by the way. Good joint. here. Crossing my screen. We'll find out soon enough, and if we are, I'll just some tables are let the red green colorblind wiring get somebody. It's fine when I'll say it when it's obvious, like when the red is really red, but when you get a muted red or a brown, the red and brown right next to each other, it becomes all kinds of hard for me. Okay, we're gonna have 4 wires there joined. We need some zip ties. Eh, not sure if these are in the kit, but I've got like 15 little packs of zip ties, so zip ties, all I need. And once again, there's zip tie channels down here, so we just need to run our zip ties up and through, and we'll take these wires. Now this first one, I don't want to pull it real tight. I want a little bit of relax here on this first lane. Don't want these wires pulled tightly here because if there's it's coming down right at the cut end of um, a slot of extrusion. So if it's real tight up against there, it's going to be pulled nice and tight. And if there's enough vibration, it will cut through that wire there. We're just going to be careful, and we'll just keep pulling the wire over to the left some as we go through and do these. Hmm. Like looking at here, and I find it interesting. So there's LEDs. It's only showing one RGB connection and one that's reserved. What is the ERCT? The ERCT is showing the same exact wiring. So there's two different sets of LEDs on this. There's ones that go in the front that are part of the um, lane lights, cart lights, whatever we want to call them. And then there's one on the on the back edge here that would be for the Enraged Rabbit Carrot tail to signal that it's got filament. So I'm curious if, like, are they just joining them together and making both strips a single strip? If so, how is it being addressed, or is it being or is there another RGB connection that's not listed on that second? Rather than being between the lanes, all of those connections are right at zip tie joints. That's once again because I left a little bit of slack here at the beginning, not trying to make things all nice and tight. Wanted a little bit of slack here. So there's one strip of lights that come on the back, but there's a strip that goes on the front as well. So that would be a lane indicator light at the front. Or is it a either or? I don't know. The thing with the lights is it's just kind of ambiguous, right? It's telling you to install lights, but it's not telling you why or for for what purpose are you installing the lights. I'm assuming that it'll tell you why the lights are useful in the Happy Hare, but we're not there yet. And once again, these would come around the corner like that. So there's our wiring running down the bottom. Once again, we've got the end stop and the motor. So the gear motor is already connected. We'll need to install the, we'll cut and do the end stop wires here. And this wire goes to this very first end stop right here. Collector end. So it doesn't need to go that far. And these will bunch up. We'll bring these around up. Probably zip tie them like right here. And bring the motor wires up down here over. Collector wires don't need to be that long. Trying to cut some blue and black wires, and I know there's another set of blue and black wires in there, so I don't want to cut the wrong set because that would be bad. Yeah, if anyone's done the ERCFA and has some info for us, that would be great if you could share as to whether it's one strip or the other strip, both strips. If it's both strips, do we connect both strips together? You know, yada, yada, yada. We need 2 more connectors and one of the 3 pins. Oh, at this point, I'm surprised. Well, no, I'm not. I was like, I'm surprised they didn't tell me to run the ground into the ground loop on the cottontail, but you don't necessarily have to run the cottontail. So if you're running just the vanilla ERCFA, you wouldn't have the cottontail wiring in here. Pull this out so I can strip and crimp these. Oh yeah, the lights can definitely be installed later and configured later. That's not a problem. I was just curious whether it's one set, both sets, not at all, because the on ERCFA, and this is interesting. Let me show you this. On ERCFA, which is what we're looking at right here, it shows the LEDs coming. Now I'm going to do some desk scroll. Bear with me. Okay, we start coming down here. Introduction, find thoughts, calibration tool, heat set insert, and then using the CAD file, upgrading the different parts that you would need to print out. And then it starts talking about doing motor wires, right? So you've got motor wires, gear motor wire, sensor encoder, wire buses. So this would be the servo, the encoder, and the end stop on your ERCFA all going into the same Molex microfit pin. Now, so the Molex microfit thing here is for doing home runs all the way back to the main controller underneath your printer, right? There's nothing that says that you can't do your connections just like that and still run it down here to a local board, right? Which is something I may do on the next one just to make wiring in here easier, right? Um, because this should be a 6-wire bus with a wire to control the apron LEDs, but we added them late in the development for RC1. Okay, great. Here's gear motor wires if we're doing a local MCU, right? This gives you what the lengths of your motor wires should be. Then it talks about wiring the LEDs. So the default option is to use a pre-made flexible LED strip, which we have one of those. But unfortunately, you'll need to cut it up and solder them together in series, similar to what they're showing you there with the standard one, right? For the wires between each LED, cut 20 millimeters, this, that, and everything else. If using a local MCU, the connection between the first LED and the MCU should be about 250 millimeters. If using a remote MCU, the connection between the LED and the Molex plug is 175 millimeters. There is an LED circuit board in development but not used. I like this. Gate 0 with your pen. Okay, now mind you, gate 0 is over here. Gate N is over here, and it shows the connector being here with a 250 millimeter lead to it. To go from here all the way to a board, I mean, 250 millimeters is that far. because it's going to mount down here on the front. That's not getting it there, folks. Now, if you started with your first one over here, that would give you plenty of ability to come around and blah, blah, blah and join in. So the wiring part of this manual just seems a little sus to me. And this is the last thing it tells you about it, other than it says to, the default option is to use pre-made flexible strip. Suggested method is to stick the segments of the LED strip to the inside of each of the cover body, and attach all the cover bodies to the extrusion and solder the short pieces together. So the cover bodies, now I need to find the rest of the printed parts. So we've got the diffuser piece. We've got this cover piece, which prints with a print in place thing. And we've got these. So this clips down in here with the diffuser in place. So you put your diffuser in, provided your hole is not too small. Mine appear to be. So you put your diffuser in, and you're going to put your LED down here in this bit. Probably just set your diffuser right on top, because there is a depression for the diffuser to sit there. And then this clips over the top. So this must just be a clip-in piece. But yeah, that was just me looking at the parts. There's nothing else in here that tells you how to install this or how to wire it, which is just a little bit annoying. That's another reason why I kept it till later, because the instructions are just kind of blah. Yeah. Well, that's what I figured, is it's going to be in what order. You just need to work on your config to tell it in which order the light sequence is, and then which order the light sequence is, and how many lights you have in the sequence. And that's what I'm saying, is looking at the MMB board. Yeah, it's an I2C, an MOT sensor, a sensor, an RGB. So there's one RGB on this board. So it's almost like you'd have to plug the two strips into one another and then work them to the back. But anyhow, let me get these two wires crimped. And I'll stop going on my rant on LED stuff. It is okay. You're throwing up a Discord there. Is that the ERCT Discord on probably the Voron channel? Oh, where did that bring me to? Voron ERCT. in your comment. They got you. Got you. Got you. Thank you. Yeah, we can address the individual LEDs on the strip. So the once again, the Enraged Rabbit Carrot Feeder has the lane indicators on the front, but there's also an option for indicators on the back, but you would have to join those two strings together at some point going into, and all of these are showing, you know, this, and then going into the RGB. So if this way is going from in over, it's almost like you'd want to join, bring this through here, come up and join. I don't know. We'll figure it out. I'll watch some other people who have done builds. I'll see if was it Lee Marie did the lights on his, and if so, how he put his together. Finish watching it. Same wire. Yeah, do whatever I want and then configure it. That's what I'll do. And like I said, it's pretty easy that um I can use the um um so I can start with a set of lights on the front, and then if I need these rear indicators, I can add those in. So I can wind up with two different sets of indicators, and it's just at that point, like I said, it's just a how do we change the config to make it work? More of a software configuration game at that point. Mess around. Means I need to extend the servo wiring to somewhat match this. Of course, I don't have any wire that matches this color. That would be uh, spin this, run it through the cable chain, install the cable. Now, the big thing is the cable chain here does not open up. You're feeding through the cable chain the whole way. And I think that might be why they gave us the cable chain in sections rather than a big of it, because it'll make it easier to be able to push these ends through like 3 or 4 lengths full stretch. But we need to do this. I can do my LED wiring going this way, loop it down under and bring it in another time. Yeah. Just wish I had, kind of wish I had gotten an turbo extension. Thought I had one around here. Speaking of servos, we were talking about the Dio build earlier and needing some new servos. So we've got, I went ahead and picked up 3 of the HS65 HBs and 2 of the HS82 MG. I can either go with all 3 of these in the head or 1, I think, in the neck or in the head box, and then 1 of these in the neck and the head. I've got to make my final decision on which one I'm going to use, then just go ahead and these are higher torque rating. I just need to make my final decision on which ones I'm going to use where, print the new parts so I can rebuild the head. And Dio should be up and running soon. And there's not extensions because that would just be that would have been cool if there was extensions. Um, what do we do? Do we just pick 3 random colors and this is what, orange, red, and brown? We got what's this servo wire? Is that any gauge or what gauge is a servo wire? Because we could just use the excess of this and run. I guess we'd run like blue, red, green. Blue being the orange, the red being the red, and the green being the brown. Got a decent amount here. Well, servo wires that don't match a standard servo wire pattern color, that'll be great. That'll go well with any of my builds. Once again, the best thing to do would be to get extensions, and because they're going to be in cable chains, to solder those extensions on versus using the the physical connectors, but I don't have any additional servo wire itself. So we will, once again, we're going to use the blue, the red, and the green. The green will match the brown, blue will match the orange, red will match with red, because why not? And here we could also use those solder connectors, but it's going to make it a little bit bigger in this cable chain, which is kind of a tight fit. So I think I'm going to go with just doing a straight up, oh, what am I thinking? Just doing a straight up standard solder joint with some heat shrink. Use my words when they come to me to be able to do some pretty short links. There, solder station out. And our solder stuff set up, I should say. Plan will just be to do one wire to the other. Okay. Any bit more room. Found the green. Well, the problem with that is then I'm going to be doing them like at the servo. So we're going to have these in the cable chain. Now, where these connections are going to be is right down here at the bottom. So they're not going to be flexing around as much. So we should be good there. So yeah, that was another thing that I was going to be concerned about was having, you don't want any type of joint in the part of a cable chain that is actually turning, right? Or making the bend, because that's a perfect place for wire fatigue to hit and occur. So with it being further down here where it should never do anything more than just lay there, we should be okay, right? Um, and if I have a problem, I know exactly where it'll happen and where it'll be. I tin these wires. My green up down. Bit of heat. Just like that, we're going to have a nice solder joint, one wire down. Now next up is going to be the middle wire, which is red. Same thing. And I can't say like, oh, well, that's the kit guy should have given me a longer wire. I mean, that's standard servo wire. You're not going to get a servo with a long lead unless you're doing like a pretty hefty servo. Down. I'll put the heat shrink on it in a minute and do all that piece. Do all three of those at once with shrink. One of the other things that you can do is stagger your joints as well. That way your actual um, solder joints or butt joints will be at different locations. And that will also reduce the amount of space in your cable chain taken up by the thickness of your wires. Okay, those three wires are joined together. Let's get this stuff myself. Map a chain however you want. Okay? Not sure what that statement means. Nick? this one over here. So I need to do heat shrink tubing. Yes, no. So that's we'll hide it out from previous streams. No, we don't. Oh, okay. I got you now. Related to your comment about the Happy Hare. I got you. Yeah, and that's what I figured is I'm pretty sure there was a way to do it, and it would be in the Happy Hare configuration on how to set the thing up. So no worries. We'll get there. I think like physical install to the printer and configuring the board and all that will be next stream because we'll have to do the CAN bus stuff, and we'll probably do that on the bench next to it. Meaning, you know, bring the printer up here and leave it on the bench so that we can have ready access to um, the Raspberry Pi and this board so that we can just get it talking and get the board itself configured, and then we'll go from there. We'll have to get CAN bus or Catapult and Klipper on it. And I will do that on stream rather than do it off stream because we haven't done a MMB before. We've done plenty of mantas and octopus boards, so doing those on stream, I'm not sure if it has any additional value over the ones we've already done. But doing the MMB, I mean, should be straightforward, same thing, but it will be a little bit different. Oh yeah, I've actually gone so far as to do it on the bench, and I've. Did you know that you can run a CAN bus board with 5 volts and a high low? So I've actually tested out an SB2209 still running 5 volt through the USB and a CAN high low and tested it out. I mean, you're not going to heat up a hot end by any means, but you can test those things. And I'm thinking I may put another, like a larger piece of heat shrink right over the top of these joints just to provide additional like support right there as if the wires were still joined together. Question is do I have a piece that will get up and go over those? Basically the same as an SB2209. Well, I figured it was. I mean, it obviously has more outputs, but it shouldn't be majorly different from that standard. To do what I want to do. Now, whenever I have long runs of loose wire like this, whether it's motor wire or anything, I'll normally go through and put like little bits of heat shrink just to kind of keep them somewhat together. I will not do that here because we're going to go through a cable chain. But, you know, if I'm going like sort of quasi umbilical-ish, or like I was running the XY wires down under the deck and around, it just makes more sense to try and keep the wires related to a component together as well as possible. I guess I can do it a little bit here. We'll do it a little bit. Yeah, I've got a smaller. Like I said, they're not big. I just do, you know, small pieces. You're not trying to heat shrink all of them together. You start twisting. Well, yeah, you could do that too. You could do that too. You could sit here and braid your wires or twist the wires. That'll work too. I forgot about that. As long as you remember what wire was what, if it's color coded like this. Um, Especially on a 2-wire. Like when I make my own CAN bus, I will make um, the high low would be the 24 gauge, and then the power I normally do 20 gauge, and I will uh, twist the 24 gauge, and sometimes I'll twist the 20 gauge. You don't have to. I don't twist them together, all 4 of them together. I twist the 2 pairs separately, but it just goes a ways to keeping things pretty tight. And one, when you're doing CAN bus, you need the twist to deal with the wire lengths and to mitigate EMI. And I've made cable chains for all of my EBB 36s, which would be my two my two 0G Mercury ones, and it was a Rook. Um, but yeah, I mean it's easy enough to do, not hard. I probably don't need the full length that I got here, so Okay. Now we need our cable chain pieces. And I don't know how many we need. We'll figure that out. We're fully at the end here. But what we're going to need to do is take our wires, like I said, and feed them through. Now we have the outie here, which means the piece that needs to be coming in is all these innies, these outies. Need the innies to go in first. And once again, trying to get these wires through, it's a good thing that they give them to you in little links, so it'll be a little bit easier to route your cables through 3 or 4 links at a time than trying to get through like one big cable chain in one shot. Okay, so there's one little section. Need grab the next section that we have, making sure that the innie goes through first. Wires go through the innie side first. Worry about getting them in the orientation later on. Now we're just worried about getting our through various sections out. Only me would have the wire come out and get stuck in the actual hole of the piece. Where I say we take the innie, the outie, and you should be able to get the outie. Pretty thick walled stuff. Cracker. Sometimes the smaller cable chains are more of a pain in the butt than the other ones. Hey, Chris, how's it going? Welcome on in. I am sort of paying attention, but I'm paying attention to trying to shove wires through small sections of cable chain. And like I said, I don't know how many links I actually need. I can look at the manual, and I'm pretty sure the manual is going to show some number, but it probably isn't going to be a correct number. It all depends on how many lanes that you, how many lengths you're going to wind up needing. At least 3 or 4 more. Yeah, I think it looks more like a typewriter, like an old school typewriter. What is it with wires going into the hole of the link? Like not the top and bottom, but the actual hole that the next link will join into. What do you guys think? Does hope you guys will be over here. Does that look good, or do you think we need one more link in it? I think it's going to do good. I think that'll do good because that's full travel. Seriously think I've got enough parts on hand, or at least close enough that I can probably build another one of these with just the parts I have on hand. One side on. Probably would have been a lot easier to get on and snapped in without the cottontail on, but I'm a glutton for punishment. So we got the cottontail on. We put off the wiring till the end. What am I catching on? Really, 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 really hate these smaller chains. Anybody has a trick for how to get small chains on, I'll take it. Oh, oh, I think we got it. I think we were successful. Catching up. Okay, so now we've got two extra long cables coming out the side that we need to add connectors to. Add a zip tie right here. Add some connectors too, and we'll be pretty much done with this build. This is kind of crazy. Now we're just say prettying up the pig. By that I mean just zip tying things and getting our wiring made pretty. Footer is the turbo. Motor first, turbo. Here, so our had plenty of encoder length here. More. Because now we need to peel these back and put new crimps on it. probably need to get the MMD wiring guide up. Make sure I'm putting these wires in. Doing over there talking Spanish. And thank you, Nick, for recognizing KB3D and his. Oh, hey, Chris, were you able to get in contact with the Fetus folks? Not, let me know and I'll try a different avenue. How goes your prep for Rocky Mountain? You guys ready to go and figured out your travel scenarios and stuff? I know you're wondering like, were you gonna ship? Were you gonna drive the whole way, or how? You Oh, okay, no worries. Trying to get the new shop spun up. No worries. I just figured I'd ask. My thing was, is if you had reached out to them and they've kind of ghosted you, then let me know and I will ping the contacts I have. Be like, hey, listen, I want to buy your product, and I want to buy your product from these people. Got You got to talk to them. When you say new shop, you didn't move locations, right? You're just talking about a web front end. I noticed you've been doing a lot of changes to the website. Oh, you physically? I didn't realize that's what was going on. I did not realize that. You should have mentioned it. Never know. I may have come up and provided some helping hands. Um, I need. What do I need? I need. For the MMB board. He broke something on his website? You're so bored? I bet you are. I bet Chris too is just bored to death, has nothing to do, huh? Nothing to do whatsoever. All right, I'm just going to go into the MMB user manual here because I want to verify pinouts. I'm just kind of going off the diagram and should be good, but just want to verify. So our board is flipped 180 degrees from this right here. So all of our switch pins for our steppers or end stops are say against the edge of the board, which is how these have been wired. The middle wire is the ground, which is how the lanes are wired, the common ground, and then the end stop coming from selector side is wired up that way. Which one am I doing first? I'm doing the encoder motor first, right? Yeah, the encoder. So the encoder, we should have white would be the top connector as our signal. Ground would be the middle connector, which should be the black cable. So hope they red would be the 5-volt, would be the bottom connector. So white, black, red instead of black. That's going to go into doing the encoder, and the encoder is the second. Encoder goes in the sensor. And then our blue, green, red cable, don't ask Chris. We needed to extend our servo motors, and I wasn't about to make new cable. We're going to go over here. I'm going to be able to cut these shorter. Be the next jog up. And so the blue is our orange, which is the signal. Red is power, which means the green would be my brown, which would be the ground. I remember my servo color coding. No, the orange is. I did wrap up BB Guide on Monday. The bed is hung from the belts with care, and it's moving smoothly. I should say. So yes, it is there. So we will be starting section 4, which is the XY motion on Saturday. Saturday could be a long stream because it seems like there's a pretty decent amount in Guide 4. That's going to keep me on my toes. Now, I did see in the, hold on a second, I'm out of the, oh no, wait. We've got like a whole other section of 3-pin in here. Good. I thought I was going to be out of 3-pins. Now I did notice at the end of section 3, the second or is at the bottom. At the end of section 3, it was talking about doing the the set screws into the belt tensioner blocks, and it actually had the caveat that if you used a plastic resistant to chemicals, then put Loctite on them. I still would say you shouldn't use Loctite on any of those set screws that are holding the belt in. Like, really? That set screw is going to dig into the belt. It's not going to. I don't know what Loctite would do for you in any one of those scenarios. Now, if it was a metal part, like a metal block that was a CNC machine, then yeah, that would make sense. But with it being a printed part, it doesn't really make sense. Oh crap, I was supposed to be taking notes. Ground power. This is going to be the signal. Servo motor. And we still have the RGBs that we can install, but I'm not going to install the RGBs at this time. May down the road, but for now, we are good without ergobas. No ergobas needed. I'm glad you like the color scheme. I think it turned out really, really well. Um, yeah, I'm happy with it. Like I said, I'm gonna have to order some white rails because this is gonna mount on a white printer, so it makes sense that the rails and everything about it would be white as well. Um, but for the time being, leave the um sorry. I'm gonna cut my own out of some black stock that I have, but because this is gonna go on a white frame printer, I'll have to order some white ones from uh, DLL PDF, and that way everything matches and looks pretty, and all of that goodness. Okay, so get the tools out of the way there. Some extra cable lengths that we'll toss over there in the cable pile. Clean up a couple of things. What's Chris doing? Thank you for gifting Kit Skyfire a sub, KB3D, Chris. Appreciate it. So let's take a bit of a look. These properties back over to that. Okay. Uh-oh, we got a hype train going. Holy crud. Oh, and hey, Urban Monkey, thank you for popping in. And yeah, I really like this color scheme. It's working really, really nicely together. Um, so KB3D gifting a gift sub to Kit Skyfire. Just paint it with white color. I might. We'll see. But I don't know if painting would work for it. I don't know. I don't know. We'll see. I think the rest of the frame was DLL PDF, and that's why I try and grab it from DLL PDF. Mr. Wiz, thanks for the 200 biddies. Nick, thanks for the tier 1 subscription. Resubscribe, basically. Appreciate that. Um, yeah, we got a level 1 hype train started. We're 75%, so we're doing good. But here's where we're at right now. We've got our Enraged Rabbit Carrot Feeder in the front part. The lane lights would go right down here in the front, and I'll do those off stream. I'll get those prepped and done off stream. The selector stuff, so the encoder and the servo motor that's in the side here, those wires come up and go through the cable chain and out the side. Our end stop wires that you can see through here, each one of these blocks has a end stop in it to tell when we have filament loaded. Filament's going to load from the bottom, come up around our wheel once or twice, and then out through the short sections of PTFE tube into the actual carts. On our MMB, we've got lane 0 through 7. And then this end one here is the selector end stop. It's over on this side. It's actually down here in the front. Tell the selector when it's over at lane 1 or lane 0. We've got our 2 motor wires set up here. We've got this is the encoder and the servo. So our RGB lights would go in this next connection right here. USB will be used to load Catapult and Klipper, and then a XT32 plus 2 will be the standard connector for the CAN bus. We don't need to bring separate power in because we're going to be bringing it through CAN. But yeah, this is all basically ready to go. I would want to install the software on this before physically mounting it on the printer. What we would be able to do is just set this on the bench right here, the printer right here on its side, so we can get to the electronics, and that way we can just plug in cables, easy peasy lemon. We're at 9 o'clock, so I'm thinking we'll how much longer do we want to run? Do we at least try to get the basic, like Klipper and CAN bus done up here? I think we can. I think we can. Let's do some cleanup. You guys are doing a hype train, so we'll go a little bit longer. Let me clean up some stuff here, get some things out of the way. Basically, it's less things for me to knock over, so that's always a plus. Things to knock over, less things to burn myself on. Oh, gifting 2 tier 1 gift subs to whom? Whom got the Mr. Zombo and Shaudell. Well, thank you. And I think that moved us into a level 2. Nope. Level 1. Oh, wait. Use now. Level 1 completed. Yes, it did keep us alive and move us into a level 2 hype train. So thanks for keeping things alive there, Chris. I appreciate that. You guys, this is so nice. Bits and subs are never required, but always good to have. It keeps the channel going, keeps the channel alive. May help me pay my legal fees when my wife gets tired of me building printers so much. You never know. There might come a time. So yeah, we got that done. That over there. We might need these wires. This over here as well. Set this over here. We'll have access to the board connections, but it's kind of out of the way because we're going to have to put the printer here, and it's a big, hefty print. Hope that we got the room. Oh, crap. Now I got to move black box out. Okay. Give me a second to we'll move black box over here. Move the rest of black box's parts on top of black box. Ever get the feeling that I'm running out of room over here? I do. There's that. Now we can move black box back over some. Oh, wait. This there, move black box into the corner. Don't worry, buddy. We'll be bringing you out on Saturday. All day. I still need to route the umbilical for the tool head, I got the cable glands. I just need to actually, you know, put it in place, use it, or use it, put it in place, and then I will cut the main umbilical wire to length and properly route it down the side here and connected. But for now, we'll lay this over on its side. Darn it. Trying to be gentle. I just laid it down there. My outlet's on. Need to flip it 180 degrees. Oh, this is why I don't need to go to the gym. This is the 3D printing gym. 3D printing workout. Just lift heavy printers several days a week. Okay. So we made sure our tool head's plugged in. We're going to plug in our printer, get it turned on, and then we'll be able to do our addition of CAN bus over on our ERCFA. Good gracious. 3, 2, 1. Hey, still no blue smoke. Magic smoke. That is good. Hey, awesome. We had 4 total subs and 200 bits. Thank you guys so much. It was so easy to set up all CAN bus stuff with that GitHub repo. Okay, you said the GitHub repo. So I'm gonna, yeah. The esoterical one. Yep, and that's the one that I've been doing. So, Adele couldn't have picked. Mrs. Dragon is one of us now. Yes, and in fact, Chris, you're gonna meet Mrs. Dragon at Remurf. So hopefully she's nice to you and doesn't get mad at you for playing to my weak-willed shopping desires. And if she asks if I have a line of credit with you, just lie, please. Just. Oh yes, I will accept that trident as a gift. Uh-huh. Get some more moving around stuff yourself. Got a space that's take that. I am like seriously, if I could find a place to rent that would fit and like rent wise and everything, I would rent it and move my printers over there and maybe do like an office and print farm, but you'll play it safe and pretend I don't know you as you're walking around the KB3D booth with, uh-huh. All right, what am I doing? So I know I'm going to need my extension wire because this wire is not going to be long enough to go from here over to here. So I will have to use the extension wire. We are going to bring up the esoterical page. So let me back over to the web browser. Okay. We've got the Big Tree Tech here. I need to figure out if I need to, we've got a reset and a boot button. Those are going to be important because I'm sure I'm going to need to use them. Is there a 5-volt jumper? USB powered supply. The USB label on the board is the power selection terminal, and a jumper is needed to short VUSB and using the USB. Okay, so we will toss a jumper in there. USB, it's right between the um, USB-C and the XT30 connector, the jumper right where the fingers at, where we made our jumper. And we're going to use our extension once again, because I know it's not going to make it otherwise. Be able to plug one end into my CB1 Big Tree Tech board. And then we'll take the USB-C connector. Uh-oh, who are we talking to? Is Talos in the... Oh, okay. So what I'm doing is I'm connecting it up to the USB-C here on the board, but I have it, so I'm connected here, but I haven't connected here. And I need to just take a quick gander here, and looking through. Ooh, interesting. So far, all of the pins down here on the bottom, let me bring this full display and show you this. So this is pretty interesting. I was scrolling through this. So on the servo, the ground's in the middle. On the encoder, the ground's in the middle. On all of the end stops, the ground is in the middle. On the RGB, it's listed as 5-volt signal with ground at the top. This is the only connector in this entire string where the signal and ground are swapped. That's something interesting to be aware of. Yeah, that's interesting. And I'm sure it's because that's the way your LEDs are, right? Yeah, and this is what I wanted to make sure that I had was like this page here. How to get into DFU mode. So we've got that up, and we're going to bring up the esoterical page, which, like you all said, and what I've said is it is an awesome page to use. I love it. The last few that I have done using this, the the only problem I have had is like the Manta boards use like Papa Delta 0, Papa Delta 1, where the EBB boards use Papa Bravo 0, Papa Bravo 1. So if you're not careful and don't pay attention, it's slightly different. That's the only issue I've had. But following this, it works beautifully. So we can say in a way that this is new build. We've already got CAN bus set up on our MCU. So it's basically like setting up CAN bus on the tool head. Because we already have Klipper on our main board, we just need to do it on our tool head board. So we don't need to do this, and we don't need to install Catapult. Already there. What I need to do though is figure out what the IP address is of this. Give me 1 second. And thank you. $19. So we are going to need a putty session set up. And this is the Manta board, so it would be BQ, BQ. Hey, we're up. So once again, we've got Catapult already installed. I'm just going to copy this, say CD into Catapult, and then do a make menu config. Here we are. It's got the configuration from the last thing we did, which would have been the EBB SB2209. What we need to do is come over to our toolhead board and look for certain parameters. So STEM32 architecture, G0B1. We're going to continue to build the Catapult deployment application in the bootloader. 8 megahertz crystal. PB's Papa Bravo 0 and Papa Bravo 1. Sorry, I was looking and getting caught up on chat. You were washing dishes, Pez Liz? Well, at least the dishes are clean. Thank you for the 10 bits. Okay, and application offset will be 8 kilobits because that is the offset that we're going to install. So that first 8 kilobits is going to have the CAN boot bootloader in it. That's what the build CAN boot deployment application is going to do, is take up the first 8 bits. We're keeping it at 1 million. Support bootloader entry on a rapid double click of the reset button. That's good. Enable the status LED. No sense in doing it. So that's where we're at. So we're going to do the standard queue to quit. Yes. Now we've had a previous setup, so we need to do a make clean before we do a make. Before we do anything else, I'm going to come back over to the esoterical. So we've got our controller done. We are going to compile with the make now that we've done the make clean. So we'll do a make. Um, okay, we're done. Now it's going to tell us to the flash connect the toolhead board to the Pi with USB and put the board in DFU or boot mode. So what we're going to do there, switch back to the main view here. We're going to plug in, and I've got a power LED down here. Really wish. What sketch do you guys want to get? Oh, sketch do we want to get? Oop, that's still not going to do it. No, that scares me. But we're connected in. We've got a power LED. Now we need to go into DFU mode, which is normally press and hold boot, press and let go of reset, let go of boot, and provided it's the standard Big Tree Tech DFU mode entry scheme, we should be in DFU mode. Okay, so to confirm that, we run a command to see if we can see it in DFU mode. And we are seeing something in DFU mode. Make this a little bigger. Run that again. So we do have it in DFU mode. And it is showing up in the standard 0483 DLL. I'm sorry. So we are getting a return in DFU mode here. So note the address of the flash, 0x8000 or whatever, and what the device ID is, standard 04EF. That's good. That means we can copy the standard sudo or the standard command down here to run and flash. See that? Paste it with the right mouse click, hit enter. We should see it do its GFU. It says file downloaded successfully, but we get the error during get status. That's cool. We knew that that was going to happen. So we should be in CAN bus mode now. So result is shown with the error during get status. We're good. Catapult is now installed. Click here for the next steps. Moves us past the RP 2040 stuff. So should now be successfully flashed. Shut down your Pi with sudo shutdown and power off your entire printer. Take out any DFU jumpers on the tool head if it needed them, and then wire up your tool head power and ground and CAN high low wire. Okay, here's what we're going to do. We're going to back to the browser window so you can see. We're going to unplug our plug, which shuts off our whatchamacallit, the Big Tree Tech board. We can put away, we should be able to put away our USB cable, flat to the other stack over here, 4 or 5. And go ahead and pull this one out. Well, because I shouldn't need this one anymore. And we need to use our CAN bus cable now to connect things up. So what we're going to do is back some. So I need these two connectors are going to go into Wagos. So what I've got here, pull you guys around. And this is the cable that's going up top to the tool head. So I've got the CAN bus cable here, and then the other two are going into Wagos, which is splitting out the 24 volt. So I'll put this other CAN bus cable in the other two ports for the power, and then plug into the other CAN bus port over here. So the downside is I do need to strip back some more of the wire to get some more wire exposed. Um, oh yeah, I'm gonna need some. So I am gonna have to um, do some wire stuff here briefly. Bear with me. Sad part is that normally means I need to break this termination. Why they only give you this much, I have no idea. If they gave you that much of the exposed power cable as well, that would be perfect. But they didn't. So I've got to do something to this end, whether it's cut it off and make it a lot shorter or something. And I know they gave me a different cable in the box, but well, I've got a bigger cable in the box. Don't know why there was a second one in the box, but it's the same way. So one way or the other, I'm cutting connectors. And probably going to have to redo the crimps on this because I won't be able to get the stuff off here. We'll do the easy way. We'll just come down here beneath it and cut it because those tips are coming off anyhow because they do that. We come back over here and grab our strippers and crimpers because I forgot I was going to have to do this. We also shut down the 5 for now. We're just going to strip a decent amount of this. Once again, this whole thing's going to have to be redone once I get get everything mounted, figure out what the cable length's going to be truly. I can cut these shorter. So this one I may not. I may leave this one long simply because it'll give me an option to continue to move things around later on. If I cut this too short, I won't be able to move it around later. So things are shut down, power is off, printer is unplugged. Rip 11 millimeters off of black and the red wires. Give these a twist and put them in bare wires because like I said, this is not the final uh, configuration for this is going to have to be taken apart and modified a little bit down the road. So good to go here for those are in. Print my oh, we'll come up and finish configuration over there. It is a Big Tree Tech CAN bus cable. It is the XT30 2x2 is what they call that cable. So it's XT30 for the power because it has a higher amp rating, and then a JST on the side, 2-pin JST on the side that provides the high-low signal wires, which are like 24 gauge wires. Pretty tiny. So the power is 20 gauge and the signal's 24. Yeah, the 3DO or and IGUS cables are really, really nice, but like you said, they are pricey. And Big Tree Tech is supplying the cables with their boards, so you've already paid for the cable. You really want to just toss it and get something else. I mean, I've used these cables on every single one of my Big Tree Tech based CAN bus printers. I haven't had problem one with it. So this in to the next port. So close that up so I don't knock it over. Funny how much I know myself. I can knock it over, I'd knock it over. We'll bring you back over here. So what we've got is the new cable. Once again, temporary, just kind of dangling down here. Positive to the positive, negative to the negative. And our high-low is crimped, plugged into the connector right next to the other one. Same configuration, yellow on the bottom, green on the top. And so it should be ready to go there. And I believe these are parallel in the same connector, so that shouldn't be an issue. We should be able to take this and plug directly into our Big Tree Tech MMB now. And once again, this is that XT30 2x2. So this is the XT32 pin by JST 2 pin. Hey, Tank Live. We're going to plug this in. Once again, we don't have power in our printer, so nothing's going on. We need to remove the 5-volt jumper. Now, I'm not sure if this requires another 120 ohm resistor or not. We'll see. If it finds it, then it does it. If it doesn't find it, then we just may have to plug in that 120 ohm resistor. Because I've heard you only need one on each end. And I don't know if this cable is a separate end because I'm not daisy chaining like the board to the Manta to the MMB, from the MMB to the tool head or anything like that. Oh yeah, can't reset the connection because the printer's not turned. So we're going to turn this. We're going to plug it in. We are going to stand to the side of the electronics compartment, and we're going to flip the switch. That way, if anything blows, I'm not standing right in front of it getting a chest full of electric arc. Okay, so I have lights here. I have light down here. Not sure if you guys can see that. We do have light right here. That's coming up and we're good. Yeah, it's not working. Is the power on? Yep, very first thing, we call that layer 0. Is the power on? End up just opening a new session. Let's go back to full display view so you can see what I'm doing and what I'm typing. So Catapult is installed. Take out the DFU jumper, shut everything down, wire everything up. We've done that. Now we're going to run this command to see if we can see that MCU over there. So we just copy paste that command and we'll hit enter. It's going to do a query and it finds something with a Catapult ID. Now I have two things plugged in, right? So there's two ways I can do this. One, I can come in here to my browser and browse over to my printer, machine, backup file, printer config. So my SB2209 CAN bus ID ends in DAB3. So the ID that was found is 0DB6. That's one way of telling it's not just picking up the tool head. The other thing is once it has Klipper on it, it's not going to be seen as Catapult because it doesn't have Catapult on it. So this is the UUID of our Big Tree Tech MMB. What I'm going to do real fast is copy that. We just grab a notepad. Surprised I don't have a link for Where's Notepad? No. Ah, that's fine. Any Klipper USB. Okay, so now we have the UUID. Whoops. And we found it, so we're good. If you don't get a UUID, stop. Something is wrong. Fix whatever is wrong. Do not go working. Do not continue. So we've got our UUID. We're going to CD over to the Klipper directory. We're going to do a make menu config. Is stop giving me extra commands. Thank you. We're into Klipper. Now we're going to do a make menu config. And we need to go through and do the install of, or the configuration for our Klipper. We're going to go back over to our GitHub site with the MMB guide here. And we want to make sure that we pull the correct settings from here. They should all be the same or pretty darn close, but we want to make sure that we have those right settings. So enable extra low level. Yep. SIM32. Uh-huh. G0B1. Yes, again. We do want to keep the 8 kilobit bootloader offset because we have CAN boot there. If we say no, it's going to overwrite CAN boot, and we would have to start using DFU mode on this to install Klipper every time. Clock, 8 megahertz clock. Communications interface. That right there is saying USB on PA11, PA12. That should not be set that way. CAN bus, we want PB0 and PB1, which is what we're configured for. Once again, SB2209 toolhead board and this MMB, the CAN bus toolhead or the CAN bus interface is Papa Bravo 0, Papa Bravo 1. The Manta board is not. The Manta board is Papa Delta 0, Papa Delta 1. It's something to remember and be cognizant of. We do not set the GPIO pins at startup, so this configuration is good. We'll quit. Nothing changed, but just to be on the safe side, we'll do a make clean and then a make. While it's doing that, we'll jump back over to the esoterical where it tells us to do a make clean, then a make. Now we're going to use Catapult to flash Klipper. So in order to do that, we're going to have to stop Klipper once this is done. Oh, Chris, just question if you're still out there. I know you've got the hats, and I know I have one on order. Was there a timeline for the hoodies? Because I know last time I was at Rocky Mountain, it was freaking cold, and thank God E3D had sweatshirts there, and I picked up a sweatshirt because my jacket just was not cutting it. Okay, so we're good. We need to run the command to stop the Klipper service. So sudo service Klipper stop. We'll give that a second. Okay, now Klipper has stopped. And we're going to query the CAN bus again. Ooh, mugs tomorrow, but no, okay, no ETA on hoodies. All righty, well, if I order a mug, can you just add it with the other order that still needs to ship to me, rather than sending it separately? Okay, so we want to make sure that we have this UUID here. Now, what I do is I build the command. Well, yeah. So I just copy and paste and cut and paste the first half, copy this, but we'll copy this command, the whole command, right click to paste it. And then before we do anything else, we're going to use our left arrow to come back here. And we need to back over that UUID. Okay. We're going to highlight the UUID up here and right click. And it pastes it right where the cursor is. Now, I'm doing this using putty. If you're using something else, it may be different. Just make sure that your syntax is in the right order. We'll have some made for us. Awesome. And that should be shipping on Friday. Even better. Even better. So we're going to run this command. And it's going, which is good. It means it's talking to our board and everything is good. And we got a the SHA hash of the file. And we've got a flash successful. So that was good. Talks about making sure you have the right set. Once the flash has been completed, you can run this command. And it should return, instead of saying catapult, it should find it and return it as Klipper. Now we see that it is showing the application as Klipper. So that tells us that our Big Tree Tech MMU board has now been flashed with Klipper. So we're good. Awesome. So as soon as I see those links up for the mugs, I'll get one on order. And then the sweatshirts, I would definitely take a XL. I think it's, let me double check. I may be going up to a double X on that just because I want them back. I think it's an X. Yeah, XL. These times, sir. So we've got catapult on there. The UUID is showing application is Klipper. Line right there. So we should be good. If not, stop. If so, hey, is now installed. Now we can run the Klipper CAN bus query, receive the UUID of your toolhead board. Maybe this is just query. Make sure it's querying it through Klipper and well, I don't know. Here's the UUID. Want to make sure and copy that UUID because we're going to need that UUID. Okay. Then we're also going to do a sudo space service space Klipper, space start. That will restart Klipper. You could also go into your interface here and just come down here and restart Klipper. So Klipper is starting and it's not complaining. That's because while Klipper's on the MMB, it's not configured in the printer.config, and there's no pins being assigned to it. So what we can do is we can take this, we'll just add a couple spaces, and I'm going to throw in my UUID. Then we're going to grab this line, copy it, paste it. We'll bring our UUID back up onto that line, and we need to give it a different name so we don't have a conflict. So this is our, is it MMB, our multi-material board. Okay. Now what we can do is a save and restart. That's just going to make sure that when it restarts, that everything still comes up because it sees that board and it's good. Right, so everything came up. We're seeing our main MCU, our MMB, and then the SB2209. Things are golden. Now, I'm going to give you guys a warning. Do not hit update all components. Do not update Klipper unless you really want to update Klipper, because Klipper has delivered new functionality that you need. The reason I say that is I did that on Iron Dragon when I was doing the configuration for the Trident 350 here. And it updated Klipper from 0.11. Whatever to a 0.12 build. And I wound up reflashing the MCU and the toolhead board and that made me have to bring it over to the bench to do it. So just be aware, update all, probably not good. You do want to come in and continuously look for and update any of the OS packages. Just don't do Klipper unless you really want to go through and play with the esoterical upgrade portion of the guide, right? I thought we had a new mascot. Wasn't it the pony? The pecker pony? That's your stick. Yeah, so update your OS frequently because you are running a web server here, and doing your OS updates is going to fix patches in your web server. Definitely a good thing in case your access point is ever hacked. People can't get into your, possibly get into your Linux boxes as easy. But just know that if you hit update all or update Klipper, you may wind up testing new parts of the esoterical guide. Okay. With that said, folks, it is now 10 o'clock. I'm tired and I still need to watch a Halo. So I'm going to go ahead and call the stream here. Thank you so much for coming out and hanging out with me. Thank you, Chris, for the gifted subs to several people. Thank you to everybody that provided biddies tonight. I appreciate it. Like I said, it goes into the channel and doing more of these cool builds. Um, and we will come back to this. This stuff will stay on the bench because what we're going to wind up doing on Thursday, um, oh, and Big Jano just raided in as I was getting ready. Hey, Big Jano, welcome on in. Thank you, everybody. Thank you for bringing your streamers over here. Uh, the party of 12. Thank you so much. There's Sally Prince. I'm sure KB3D was probably hanging out there as well. But welcome on in, everybody. For those of you that don't know, my name's Digital Dragon, aka Luke. I am a 3D printing variety streamer here on Twitch. That means that I do all things 3D printing and 3D printing adjacent, I'll say. So we build printers. In fact, we've got one right here, right now, that we've been working on a Enraged Rabbit Carrot Feeder multi-material unit. And what we did tonight was we finished the physical build of this and did the wiring. I'm trying to be careful because I do have live wires. We wired up everything on the tool head or on the controller here, and we just loaded up the basic Klipper firmware onto this board. And so between over this cable, it's getting power and talking. So the next thing I have to do is start loading up the ERCT specific, we'll say, Klipper modules called Happy Hare, so that we will be able to control this through our standard Klipper interface. That's going to be Thursday's stream. Okay. For now, we were getting ready to find somebody to raid out to. We ran a little bit longer tonight than I anticipated, just to make sure that we got this as far as we could. But for those of you that have never seen one before, this is the Enraged Rabbit Carrot Feeder, this first part here. And then this is the Enraged Rabbit Cottontail, which is the buffering system for this multi-material unit. What this means is you can have 8 colors loaded up, and the selector motor here will move and select whichever color you have loaded up in the lane based on how you've configured your slicer and sliced your file. Okay. So that's what this is. We also on our tool head have the Enraged Rabbit Filametrix. That is the tool head cutter. We also have a couple of sensors in there that will tell us where the filament is within our stealth burner tool head, which will enable better troubleshooting. Like I said, language sometimes, English. But that's where we're at, and we've reached a logical stopping point. So Thursday is going to be all Happy Hare and just trying to get things initially set up and configured for the ERCFA. I can't guarantee that we're going to push plastic on Thursday through the ERCFA, just that we're going to start working on the Happy Hare and trying to get things configured. But yeah, that's kind of where we're at. Thank you everybody for coming in. I will try and set this printer up, probably put, just set the top panel in place, put the ERCFA on top of it so I could take some pictures to post our status and progress on Twitch and everything tonight. But yeah, thanks everybody for coming out. Let me look over here and see who we can raid into, because I need to grab something to eat and, like I said, watch a Halo episode. Trying not to get too far. But let's see who's on. Is let's see, got Profit DNA doing a Lego build. Ette Heresy is working. Creatix Brit looks like she's got some words going on. That undead yard rodent is working on adding a third tool to his tap changer. So, hey, I normally am not on long enough to be able to raid into the undead yard rat, what we'll refer to him as, I guess. What the hell is the hot? Still getting started up. Dennis starting, but he's going to be starting here shortly. So I will go ahead and get the raid started over, and we will raid in while we're started. Just because I'm sorry, I pushed it a little long tonight. My apologies. But thanks again, everybody, for being here. Run over to Zombie Hedgehog with me tonight. Let's give him a hard time. Let's heckle him, see what he's doing this evening. And thank you all once again for being here. I will see you guys on Thursday. Good night, all. Bye.